Okay, guys. First of all, I'm going to show you the equipment, how it works, how it runs. For any TIG welding application, you need straight arc. And you need a constant current welding supply. So constant current means you can TIG weld, you can stick weld off of it. On these wire feed machines, those are constant voltage. They work on a TIG weld. Constant voltage is for MIG, constant current is for TIG and stick. So what we got here, down on the bottom, we got a workpiece, which can be a TIG torch or my stick electrode. Okay? Plug that into the side where it's got the little icon where the stick welder is at, and then take my ground clamp and put it in the work lead area. Work lead is another word for a ground clamp. Okay? Now, I also got right here on my 14-pin connection is my foot rheostat. That down there is just a little foot pedal that energizes my torch and also allows me to adjust my amperage out where I'm welding. Sometimes you'll see you can do a fingertip control or foot control, or nowadays they even got a little wireless remote that you can put a plug in there and have a little small little box right where you're welding. Just hit the buttons if you want more amperage or less. Okay? All right. Now I've got some icons here too. I got a picture of the TIG torch. Got a picture of an electrode holder for stick welding, and I got another TIG torch for the AC. Anytime you do steel or stainless steel, you want your electrode negative, a little negative sign. So you got to put it in the negative side. If I want to do aluminum, I come over here to the AC side. If I want to stick weld, I go over here and my electrode is positive. Ready to stick weld. Okay? Now. And then the negative side, it popped up here, it says DC electrode negative. Now I put my TIG welder in the TIG mode. I come over here and I can adjust my amperage. I want my amperage on my foot pedal. Let's say I've got 160 amps right now. When I put that foot pedal all the way to the floor, I got 160 amps. Now if I don't need that much, I can back that foot pedal off and we got a range we can go in. Okay? Now if I want to stick weld, I come over here and put my icon in the stick welding mode. Here I can adjust my amperage again. Okay? I'll go back to TIG. I'm going to put it right at 150. My gas should be about 20, 25 on my working pressure. And what that shielding gas does, actually what it is shielding gas. It covers the atmospheric air when your puddle's in a molten state. So you don't get contaminants in it and stuff like that. Okay, that's the machine. Now I'm going to take apart the TIG torch. This is what they call a cap. A lot of people in the industry will call this a rooster tail. Some of the pipe fitters call that. That's a TIG torch cap. There's my electrode. And for what we're doing today, mild steel and stainless steel, I want this to be a 2% tungsten. That's what we got today. Now when you prepare your tungsten, you've got to grind this to a point when you're doing stainless and mild steel. And you take that up to the grinder, and a bench grinder, and you want your wheel to rotate parallel to the tungsten. And then just taper it a little bit, turn it, don't get it too hot. So you get the blue marks on there. You don't want to get this hot. And just taper it to a sharp little point. That point should be about 1.5 times the diameter of the tungsten back. Okay? Now, if I take that grinder and if I do it like this, and the wheel rotating this way, I'm leaving grinding marks on that tungsten around it instead of up and down. And what that's going to do is make your arc wander. It's going to kind of be goofy like circles and stuff like that. So when you got your marks going the right way, that focuses right into that puddle. Okay. This is a collet that goes over the top of the tungsten. And this cap will push that down into what they call a collet body. Which is this piece right here. It's also a gas diffuser. There's some holes in there and that gas goes through there. And then you cover all that gas up and make it go in down into your puddle, you got a shielding cut. Okay? So we'll put that back together. And if you get different size tungsten, you got to get the appropriate size collet and collet body, whatever size you use. Okay, you want that to stick out, maybe about 1/4 of an inch or so. So you can see what you're doing. If you get that too far out of there, you're gonna have to increase your shielding gas so it covers it pretty good.
So Dwight, does that come in like a longer rod, like your electrode here? And you cut it down to size to fit?
No. The electrode comes in a 7-inch piece.
Okay.
And when you don't want to touch this tungsten to the material because you're going to contaminate it. And it's going to get all messed up and slag on it, stuff like that. And if it gets that way, your arc is just going to go crazy on it. So you need to take that out, bust that piece off, go back to the grinder again and clean it up. Okay? Now, you can get, so let's say we're doing it in a tight space. I can get a cap that's half this length, and I can get a cap that's really short, what they call a button cap. And you can break your tungsten off to fit that cap. The tungsten's consumable. It'll wear out. You got to keep it clean all the time. Okay? That's probably about it as far as the equipment goes. Now what we're going to do, I'm not going to fire the torch yet, but it's always good to drape this over your lap or over your shoulder so you don't have the weight of the torch hanging out there with your hand. So what we're going to do, we're going to come in here and we want to bisect that angle and then have a little bit of a lead angle on it. And we're going to push that puddle just like when, have you guys had oxy-fuel training at all?
No.
No. Okay. Similar to oxy-fuel, you're going to establish a little puddle here. When you see that puddle, you're going to start pushing your torch forward. You're going to push your puddle forward. Then we're going to come in here with our filler rod. We're going to get it down low there, and we're just going to gap right in the front of that as we're moving forward. Give it a nice, pretty easy.
Is there a certain angle you want to come in at?
On
with your filler? Yeah.
Oh, probably about a 10-degree angle, maybe. Something like that. If we go too high, we're going to get in the way. We're going to contaminate our tungsten. And here's a perfect example of try not to touch this tungsten with your filler node. That's going to contaminate it. And it'll probably happen. All right. Let me get my helmet here. Let's fire this up. Pedal. Jump across.
It's just going to be
bright light. There's some machines out there that don't have high frequency, so then they get to what we call scratch start. You come in here just like a stick electrode, and that's how you get established your arc. This one has high frequency, so when I touch that pedal, it's going to go.
Let's see how this looks.
What I'm going to do, it's going to get molten on the top and molten in the bottom. And as soon as I get a decent puddle between those two, I'm going to start rolling.
That's pretty good right there.
That's running a little, that gas is running a little bit. It'll run for about 10 seconds or so to cool that tungsten down. And a lot of times guys will hold it down there too to cool that puddle at the end of it so you don't get greater. So that's what we got. On the back side, you can see I got a little bit of heat there. That's exactly what I want. I didn't burn too hot there. Got that perfect. There on the bottom, I got a little too much. I should have speed up a little or something. All right.
Zoom in tight on that? Yeah.
Yeah, did you hear a little noise there about halfway through? I touched my tungsten. Got a little shaky. There we go. That's what we want right there.
Good shot of that.
It's getting hot.
So, Dwight, you guys have, I don't think anybody here has ever done any OA stuff.
None of it?
We quit teaching that
Did you?
before these guys were here. Will you just explain the process of what you're actually doing there? It's probably hard for these guys to see as far as, you know, melting and filling that pool.
Okay. I'm not going to strike an arc. So when I'm right in here, right up close there, it starts to melt. And then the bottom starts melting too. When those two touch each other, that's when it's time to go. And I got a molten state on both pieces of material. If, we all got helmets. Why don't you guys get real close in here? It's the only way we're going to see.
Well, I'll just do this side next. Here you go.
You see that puddle on the top? See it on the bottom? Bounce together. I'm going. I just want to make sure that's always fluid. It's going to be tough to do. It takes lots of practice. Lots of practice. Now, I'm in perfect position here. Just imagine if you were overhead trying to fill this in around a pipe and trying to keep this at the right position. I mean, it's going to take some practice.
So for us to start out doing this, do we want to just run stringer beads in the flat position, or is it? Do we want to start out with the fillet weld?
I would do both. See if I can do a butt weld here. I'll show you. I'll just tack these real quick.
I can't see much as close.
There, I touched it. There, that's just do a butt weld and just do stringers. A fillet weld, yes, is good. That's the easiest weld to get good at. So that's a good one to practice. You might try taking a piece of pipe, a short piece of pipe, and set it on the flat here. Once they get a little better at it, and see how good they are coming around it. It's gonna be tough. Now, see my tungsten? I'm not as pointy as I was. It's starting to get contaminated. Now, I can still weld with that. That's okay. That ain't gonna hurt anything. And when it starts really building up, you'll notice that your arc is gonna be kind of a mess. Aluminum, just don't worry about it.
I've got some aluminum if you want to do it.
Well, we gotta do different tungsten. That's a different animal.
It's up to you. I've probably got everything you need.
Okay.
Alright, this is a lot easier. All my puddle's molten already. And I'm just following that groove. Whoops, now I lost it. I'm just dipping in there and away we go.
I wasn't, no. In fact, I can't see it, I don't even know where I was at. It will tell you if someone else is watching. Now, let's just see, curiosity, see where we're at. Okay. Now, I was leaning on this. I was perfect position here. When I got out of here, I was kind of stretching it, trying to shake a little. And I'm resting my weight on here. That's the worst thing you can do in any welding situation is lean on the table and you've got all your weight on there. Now I'm out of room, now I gotta move, now I gotta, I get drastic moves. Where if you can just rest on it, and just guide your lightning, it's gonna be really, really smooth. And that's with any welding. Okay, now he's got aluminum. What we're going to have to do, we're going to have to come over here and flip this over to AC. These are pulses. I wasn't going to go there, but we can. You can pulse aluminum, and you can get that really dime stacking look you see on some nice pretty welds. You turn that pulser on, I can adjust my pulses per second. I'm not sure how to do that. So we'll come back to that.
Here, is that what you're looking for?
Yeah.
And then I don't know, I think this is that right?
Yeah, that's aluminum.
Would you look at the aluminum box?
4043 or 5356 is the only aluminum alloys you're going to be doing. Cut that. Just cut the end of it off. Okay, you need a green tungsten for aluminum. A little green band on it. A lot of the newer machines, you don't have to do that anymore. Now what's going to happen here, when I'm on AC, that's going to ball this tungsten just to a nice shiny ball on it. Why don't you turn that big knob up to about 200 maybe?
Will that work or you want something else?
No, that'll work.
What we're going to do is something good.
All right, now anytime you do aluminum, you should always take a stainless steel brush and clean up where you're going to run a bead, where you're going to weld it. Now, if you don't have one, it's just going to be a little tougher to weld it. Don't use a wire brush because you're putting carbon into aluminum to contaminate it. So you always got to use a stainless steel brush. All right, I'm going to ball this tungsten now, just for starters. I'm just going to hold it here and hit my foot feet. Whoa. Okay, that's exactly what I want. Nice shiny ball like that. Okay, that's pretty hot. Now, it's going to be tougher to see the puddle on aluminum. You're going to get kind of like what looks like a mirror finish. It's not going to be as defined as it is on mild steel and stainless. So that kind of makes it a little tougher to see this. Nice golly. That's what you want. Now, right here is where the metal is oxidizing. Actually, what that is it's cleaning. It's cleaning the metal. When it warms up, that stuff is, contaminants and stuff are coming out. So that's what it's doing there. Any idea how hot I was? Did you guys see? How much?
140 got up to.
About 140? Okay. That's what you want. Now, did you guys see the puddle was a little harder to see? I want to get that mirror finish and kind of see it get fluid. And you start going. And you got to dump filler in more on aluminum than you do here.
Can you run the pulse on aluminum also?
Yeah, let's, okay. See where the pulsar button is? Hit that. All right. Let's see what happens. Whoa. Oh, that fire. I think a little bit. That's what the pulsar does. It's hot, cools down, hot, cools down, and then you can do thinner material that way. And now, look how much more uniform that dime stacking is. Get prettier weld.
Why would someone choose to TIG weld
Pulse?
compared to MIG or stick, or explain what the...
Appearance, a good example, let's take some of these boxes you see hanging off a semi-truck or a trailer, where they do a outside corner bead where I'm going down outside. anytime I'm on an outside bead, that heat really wants to blow through there and blow that out. So if I'm pulsing that, I can be a little bit lower amperage and have better control of that puddle. Plus, I'm getting a pretty heat out. So,
Is it a stronger weld then? Is it a
no,
stronger
not
joint?
necessarily stronger. Strength's about the same, but it's just easier to control.
Okay.
Out of position, I would consider pulse. Any outside corner bead or something, you know, appearance-wise. Anytime somebody's putting those boxes on a semi-trailer or working on their pickup where they're making an aluminum flatbed, you want that all to look good. That's why I would use pulse. Pop cans. This particular machine probably won't do it, but I could turn it down to 5 amps and get a tungsten that's probably 1/16, and I can weld pop cans together with pulse. So things like that. Putting a bead on the edge of a razor blade. I've seen people do that before. That's probably about 3 amps. And the pulsar just on, off, on, off. In fact, at that low temperature, that's about how fast it's going. Just on, off.
And all that's doing is
on,
controlling the heat for
Yep.
you.
Now the new aluminum bodies that are out now, is that something where guys, if they're repairing those, are going to pulse weld that?
No, they're actually going to MIG weld those. Miller came out with a welder that it's a pulse welder, and you can turn it down really low and MIG weld those aluminum bodies. So, but you could do that with TIG too. Either way. So,
Is TIG a cheaper process or a more expensive process than, say, MIG?
TIG is, the power sources are higher priced. The process itself is probably a little cheaper, but it's slower.
Yep.
So production-wise, no, you're not going to want to do TIG welding if you can get by with not doing it.
So is it considered more of like a specialty?
Yeah,
You would consider it a specialty? Guys welding on choppers and
there we go.
stuff like that?
Higher paying gig, I'm sure too.
Yep. I go back to the race car stuff all the time. I'm used to drive race cars, and there very, very little of that stuff is MIG welded. It's all done with TIG. They like those tiny, pretty beads.
Just because the way they want it to look, the appearance, they want it to look good.
Appearance and strength. I'm getting a 100% penetration. Plus, I got a little bead. We don't want no big MIG welded bead on there on a race car frame. Actually, you're adding weight. What
Yeah,
weight
I knew
that
you were going
is,
there.
but in the big world, that's pretty particular. Any questions? I haven't done TIG welding aluminum for, we didn't do it last year, did we?
No, we didn't, I don't think.
I bet it's been 5-10 years since I've done TIG welding.
It's like riding a bike. Look at this guy.
It's not bad.
Do you
The toughest part, and I struggle this to this day, setting your machine correctly. That's the toughest part about welding.
How did you know to set it at 150 amps there? Did you just knew by looking at the thickness of the metal, or
had a
because there's
rough
not a
idea.
I teach these guys look at the chart, read the chart, do
That,
the settings.
that's the best thing you can do is read the chart. Get you in the ballpark. I've done this enough that I've got a rough idea. Yeah, it's going to take about that
Was
much.
there a chart on this machine you looked at?
I don't think there's a chart on this one.
Okay.
It's probably an owner's manual.
Yep.
But all your MIG welders have a chart inside the lid. Use it. I mean, yeah. It takes the frustration out of it. Oh, I turned that knob too much, but then my voltage knob is now here, and now you're lost and confused. Use the charts until you get good at it. Then you can tweak it to your own settings.
Do they TIG just in the regular welding degree when they're in the
Yep.
colleges? That's part of the deal?
Yep. I've got an associate's degree in welding, and I went through all processes, TIG welding, MIG, stick, all of it. And when I graduated, I was certified to weld pipe to go into the pipe field. I never did, but that's what they taught me how to do.
All right.
Great.
All right. Well, thank you, sir.
Thank you so
You're
much,
welcome.
Dwight.